4, we have the tangent times the cosecant squared minus the tangent x. Once again, the minus sign separates them. And the first thing I notice is that I have tangent in common. So what I'm going to do is I'm going to factor it out. When I remove the tangent to take it outside the parentheses, I have a cosecant squared x left over. I bring down the minus sign. Now what is left over when I remove the tangent? What you have to remember is that this is never alone. This is 1 times the tangent. So when you remove the tangent, you have a 1 left over in its place. Alright, this should be familiar because in your identities, this is equal to cosecant squared x minus 1 is equal to cotangent squared x. Alright, so we can go ahead and we can substitute it. This whole thing is equal to cotangent squared x. And now we can change things to sine and cosine. This is sine x over cosine x. This is cosine squared x over sine squared x. And they're squared because the cotangent is squared. Okay. Things can cancel. We have a sine left over here. We have a cosine left over here. Right. So this is just 1 over 1 now. But we have cosine over sine. And cosine over sine is cotangent x. And that should be the answer. Alright, this is another subtraction, and one of the things that I notice is that in both terms there's nothing in common. So what am I going to do? Well, I am going to change everything to sines and cosines. This is 1 over cosine x. Cotangent x is cosine x, sine x. And once again, this is still one term, right? They're still separated by this sign. And I'm just going to put this sine x over 1 deal. Alright, this is multiplication, so I can cancel these. Okay? And I have 1 over sine x minus sine x over 1. Alright? And I know some of you guys are canceling this. You can't cancel. You have a minus sign in between them. This one has sine, this one has 1. So we have to give it a common denominator. Oh, something just fell. This one needs sine, so we're going to multiply top and bottom by sine x. Yay, now they have sine in common. Now we can combine over sine x. Alright, but what is the numerator? The numerator is going to be 1 minus sine squared x. You can pay attention to your identities. 1 minus sine squared x is cosine squared x. And you're like, whoa, what happened? Nothing happened. Just separate this into 2 separate cosines. And then put it over sine x. And a quick fix would be to realize that this is cotangent x. So this is cotangent x times cosine x. Right? This is preferable over a fraction because it's so linear. So this would be your answer. Alright, this is problem number 6, and the first thing you need to realize is that secant squared x minus 1 is equal to tangent squared x. Alright, so this is tangent squared x times cotangent x over secant x. Okay, and let's change everything to sines and cosines. Tangent squared x is sine squared x over cosine squared x times cosine x sine x for the cotangent over 1 over cosine x. Okay. And let's start cleaning this up. That goes away. You've got a sine x over here. That goes away, right? And we've got a cosine x down here. So then the numerator becomes sine x over cosine x. Over 1 over cosine x. Right, and we're going to change, and we're going to flip. Sorry, I'm running out of room. We're going to keep the numerator, sine x over cosine x. And we're going to flip the denominator, cosine x over 1. cosines cancel, and you're left with sine x over 1, which is just sine x. And that would be the answer. Alright, this is the last problem, and with this one you might think, oh, let's get a common denominator. But this one's kind of suspicious because the cosine and the secant are reciprocals of each other, and so are the sine and the cosecant. So what we're going to do is we're going to treat them separately, and then afterwards we're going to combine them by adding. So this is cosine x over 1 over cosine x, right, plus sine x over 1 over sine x. And of course, keep, change, flip, keep, change, flip. So cosine x times cosine x over 1, right? I'm flipping this. Sine x times sine x over 1. So what do I have? I have cosine squared x plus sine squared x. And if you go to your identities, this is equal to 1. Okay, so that would be the answer.